Hello and welcome to our presentation on the volume of composite figures. So we're going to be looking at in here that we're going to be putting together, looking at our composite figures and figuring out our total volume just like we did with our area. All right, if you haven't done the do now, please go to Google Classroom and do that. Make sure you log into the online check-in form that the school wants you to do to show that you're here. Okay, so we're going to be finding the total volume of the composite figures. So today your do now is again the one that's in Google Classroom. We're going to be going through some sample problems, putting these together, and your homework is going to be a worksheet. The worksheet is uploaded into Google Classroom. And then you are to put your answers in the Google Classroom and check them like we normally do in our class. Okay. So we have practice problem number 1. So we have a rectangular prism and we have a triangular prism. So I'm going to separate these into 2 different figures and then add them together. So we're going to do the volume of our triangular prism plus the volume of our rectangular prism will give us our volume, our total volume, which is what you probably suspected. So I'm going to do the volume of the triangular prism first. So we have the area of the base times the height. The area of the base times the height. So when we're looking at this here, we need to figure out what is going on. First of all, we check to make sure everything is in feet. Yes, it is. And then we're going to be looking for our right angle symbol, which is right here. And this part right here is our base of our triangular prism. Remember, the back and the top and bottom need to be the same. This one is just on its side. So what is the area of that bottom part? So we know the area of our base is 1/2 the little base times the height. We're going to be looking at that right triangular, that right angle symbol that's going to tell the 2 that we need together. So the 2 that we need to multiply together. So we know that the height or the altitude is 4. We know that we have to multiply that by 1/2 and we need the base. So if this and this are the same. So if this is 6, this one is 6, that means that this right here is also 6. So our base that we're looking at in here is 6. So the area of our prism bottom is going to be 1/2 of 24. And that gives us 12. So that's this figure right here. Right here. So we found the area of that right there. So we need to take and put that. The volume of the whole thing is 12, the area of the base, times the height. Now what is the height? So the height is, and again, this is on its side. So we're going to take a look at that. If this is, let me put it in highlighter mode. If this right here is 7, then we know down here that this is also 7. So then that is our height that we have. So really we have our rectangular prism, our triangular prism is standing, and then we have it tipped over onto our side. So the volume of the triangular prism is 12 times 7, which gives us 84 feet cubed. So we do 1/2 is when we find the area of the base, We don't need to multiply the 84 times 1/2 because we already have done that in the area of the base. Okay, the area of the rectangular prism is going to be the area of the base times the height. So the area of this base is down here I'll use blue. So this right here is our base of our rectangular prism. So then we're going to be using in here, we have 6 times 12. That's our base. So in here we have 6 times 12. And we're going to multiply that by the height. The volume of the rectangular prism is 72. And then we have to multiply by height. So going back in here, we're looking at our height, which is right here, which is our 4. So we have 72 times 4, which gives us 288. Let's verify that. Yep. So the rectangular prism is 288 feet cubed. So the volume total is 84 plus 288 equals 372 feet cubed. Break them apart. We have our triangular prism up here and we have our rectangular prism. The only thing that was a little tricky is this 6. So if this is 6 and this is 6. All right. So we're looking at the practice problem number 2. What is the volume of the shaded area if the radius is 4? So I'm going to put in here my center of my circle, and we have to find where the radius is 4. So I'm going to put this directly across. This is 4. We could put it this way. This is also 4. This is 4. This is 4. This is 4. This is 4. Anywhere we want to touch the circle, but we are interested in this one right here because we want right here because we want it to touch the side of our figure and the center. We could do the other way as well. Well, he has to touch our side. So by doing that, we can figure out a bunch of different things if it touches the side in here. So first of all, this means that the total diameter across the radius is 4, but the diameter is 8. So if this whole thing is 8, that means that dropping that down, this whole side is also 8. If this up here on the side, looking at this, if this is 4, this is 4 right here, then this is 4. That means that this whole side over here is also 8. And then we have 8 over here and 8 over here. So what we have is a cube. We have a cube where all the sides are the same. So in this cube that we have in here, we have, and you could put in here that we have that this is 3-dimensional as best we can. So we're going to have in here, we need the volume of the shaded area. So we're assuming that everything is 3-dimensional. So if we're looking at this volume, and it's a cube, then the length is equal to 8, the height is equal to 8, and the width is also equal to 8 because it's the same all the way around. If we were to come out towards you, that would also be a radius of 4, and going back into the picture would also be 4. So we have two figures here. We have the volume of a sphere, and we have a volume of a cube. And to find the volume total, we have to take the volume of the cube and subtract the volume of the sphere. So let's take a look at what this looks like here. So the volume of the cube. The volume of the cube is the area of the base times the height. The base is 8 times 8 times the height. So the volume is 8 is 64. 64 times the height. And then the height, again, is because it's a cube, it's 8 as well. So the volume of this little c down here is our cube, is 64 times 8, which is 512. We don't have any, oh, yep, we do. We have inches right here. So inches cubed. The volume of the sphere, you'll need the formula for it. So the volume of a sphere is 4/3 pi r cubed. So all we need to know is the radius. So 4 times pi times 4 cubed. We're going to take that whole thing and divide it by 3. So 4 times pi button times 4 cubed gives us 804.25, and we're going to divide that by 3. And our total volume of our sphere is 268.08. Now, to finish this problem off, we need to figure out what this is right over here. Oops. Oh, you can see what I'm looking for. I thought it was in yellow. All right. So, doing this total. So the volume total is the volume of the cube, which is 512 minus 268.08. And we get an answer of 243.92 inches cubed, which is quite a bit if you think about it, because we have this extra space right over here on the side. This space right here is extra space. It's kind of wasted space, and we have nearly half of it not being used in our cube. All right, let's take a look at the next one. So we're looking at, in here we have two figures. We have the volume of the shaded area is what we're looking for. So we have two figures. We have the volume of a cylinder and the volume of a rectangle. So we're going to take the rectangle is on the outside, so the volume total is going to be the volume of the rectangle minus the volume of the cylinder. The volume of the cylinder first. We have the area of the base times the height. So the area of the base times height. The volume of the cylinder, the area of the base is pi r squared times the height. So in here it tells us very clearly that this is 5. So looking at this in here, we can see that we're going to do pi times 5 squared times the height. So 5 squared, 25, times pi gives us 78.54 times the height. Now the height right here is this value. Right here. And that's 20. So we have 78.54 times 20. And that gives us a volume of our cylinder is 1,570.80 inches cubed. Trying to keep this a little clean, we'll do the volume of the rectangular base, the rectangular prism. So we have the area of the base times the height. The base in here, can't really tell, but you can do a couple different ways with a rectangular prism. I think some of you have already figured that out. We can call this our base right here if we wanted to, and say that it's laying on the side. And we can do that because this over here, even though we can't see it, is exactly the same. They're two different things. So looking at this in here, you can see that this 16 times 16 is our base, and that is a square. The volume of the rectangle is 16 times 16 times our height. So 16 times 16 is 256. And then we need to figure out our height. It says very cleanly here that this is 20. Gives it to us nice and neat. So the volume of our rectangular prism is 5,120 inches cubed. So our total that we're looking at over here, our total volume is going to be 5,120 minus 1,570.8. And that is going to be 3,549.2 inches squared. And that's the shaded area. Now, if I were a business, that is quite a lot of wasted space. I would use a smaller box. I would definitely use a smaller box for that value. All right, so you can kind of see what we're looking at in here. So we have the area of the base minus height. If they're inside each other, then we subtract. If they are like this, that's subtraction. But if they're on top of each other, we just add those together, and we have our volume of our two prisms added together. All right, have a good day.